let's apply what we've learned about radians to different scenarios. And just to review a little bit, radians are an alternate way of measuring angles. We could measure an angle in degrees, of course, 90 degrees, for example. Or we could say it's pi over 2 radians, which has everything to do with the circumference or fraction of the circumference on the unit circle, unit meaning 1. So if I traveled from here to here, I would have traveled half of a pi. Like if this was a mile, and this was one big circular track, this would be half of a pi, which is about 1.57. This is about 1.57 miles. Okay, just quick review. An angle with a measure of 4 radians intercepts an arc with a length of 18 feet. Okay, so here's the visual for that. We're gonna have an angle, whatever it may look like, and it's gonna have a measure of 4 radians. Well, just to be clear about what 4 radians is, if pi radians, that'd be 3.14. So a little more than 3 radians is here, then it's gonna be somewhere around in here is 4 radians, okay? So I'm gonna draw a circle actually, and I'm gonna cheat and use this to draw my circle. And you have seen this type of problem before. So I'm gonna start my angle here, and I'm gonna end it here-ish. And this measurement around here is 4, not 4 degrees, but 4 radians. And it intercepts an arc with a length of 18 feet. So the arc that we have intercepted goes from here all the way around to here. That was poorly drawn. And that's 18 feet. And I want to know the length of the radius of the circle. We'll call it r. And we're going to find out what that is. And we're going to use a formula that we have seen before, but we're going to apply it in a different way. So I used to write that the length of an arc, and I'll just use L, would be the measurement of the angle over 360 degrees. And I'm going to multiply by the circumference of the circle. And this is true, 360 degrees. But in this case, I'm dealing with radians, so 360 degrees or 2 pi radians, whichever measurement you're dealing with, because one full circle, instead of calling it 360 degrees, we can call it 2 pi radians. So what we're going to do is deal with the length, which is 18 feet. And the angle is what we also do know, so 4 radians divided by 2 pi. Often if they're dealing with radians, you will have a pi in the problem. In this case, we don't. And 2 times pi times the radius, which we don't know, and that's what they're asking for. Something wonderful is about to happen here, and this is the glory of radians. Those things cancel out, and it's going to happen every single time. So 18, whoops, wrong color. Man, switched colors. What was I thinking? 18 equals 4 times r. So for r, we're going to divide by 4, and r is 4.5 feet. Let's tackle the next one. An arc has a length of 48 inches, and the radius is 6 inches. What's the measure of the central angle that corresponds to this arc, measured in radians? So now, same formula, but now we're looking for the measurement of the angle. So draw a circle if you would like. Doesn't have to be as pretty as mine. There we go. There's our circle. And we don't really even know what the angle is. So don't get all technical and be like, well, is it a big angle? Is it a small? Is it acute, obtuse, super obtuse, ridiculously super obtuse? Like, who knows? It doesn't really matter. What I do know is that the arc has a length of 48 inches, and the radius is 6 inches. And we do not know this angle right here. I'm going to call it theta because it's an angle, and I like to use Greek letters for angles. What is the measure of the central angle? Okay, so same formula. So the length is the angle divided by 360, but they say radians, so 2 pi, multiplied by 2 times pi times r. And if you want to just go ahead and jump straight to where this thing is going, you could say, well, you know what? 2 pi cancels with 2 pi, and I am left with, and let's start plugging things in at the same time. The length of the arc is 48, and I don't know the measurement of the angle, and I do know the radius is 6, so 6 goes into 48 8 times, so 8 radians, not in terms of pi.